For the third time, apologies for the technical difficulties. Thank you everyone for coming. My name is Daniel Imberman, and this is Airflow and Kubernetes. Just for those of you who weren't here, I'll just start from the beginning. We weren't too far in. I'm also joined here by Anirudh Ramanathan from the Google Kubernetes team. So he will hopefully thank you for joining us, Anirudh, also for to help us with some of the Kubernetes perspective. So without further ado, this is Airflow and Kubernetes. Just to once again give some background perspective, we here at Bloomberg are working to use Airflow as kind of a Kubernetes launching platform to work with our data scientists. So we want our data scientists to have a lot of flexibility, both in the languages that they can use and the frameworks they're using. And we also don't want them to have to worry about the actual internals of Kubernetes. We've had a lot of issues in the past where people build pipelines that involve like doing certain steps in EC2, certain steps in HDFS, and then you have to worry about like, does Yarn have the right dependencies? So Kubernetes handles a lot of those dependency issues and gives a lot more flexibility to those data scientists. So as far as the actual system overview of how we worked on these Kubernetes tools for Airflow, there were three main things we had to worry about: launching jobs, monitoring those jobs, and then handling errors and bubbling them up so that the user can actually see them. On the launching job side, there's two things that we wanted to create: a Kubernetes operator and a Kubernetes executor. The Kubernetes operator is, of course, on the user side, and we currently are taking the opinionated stance of having a factory model where the users generatively build out their pod like arguments. The reason being that we wanted to have as much of the actual pod creation visible in the code itself. We're open to discussing having EML integration, but our main concern there was that would make it very hard, like with the external dependencies where people might have changes in their Airflow DAGs that they don't realize from the Airflow code itself. We're using the Kubernetes Python pod client. And one thing that's really cool about this pod operator is that we can actually use it to create higher level operators that handle a lot of dependency management issues in Airflow. So for example, let's say you wanted to create a scikit operator where you ran certain numerical operations in Python, but you don't want to have to download all of scikit into Airflow and then so that you have access with a Python operator. You could potentially create a scikit operator that extends a pod operator and have a pod that has all the scikit dependencies that you want in it, and then just either like port over the actual Python file to run it and do all sorts of internal operations that are completely abstracted away from the user. This also gets really interesting in the future if we can start integrating Helm into this, where Helm is basically a homebrew for Kubernetes. You can use Helm to pre-configure entire clusters. So there's currently a Helm script that has like a Spark, like an entire Spark executor and driver and a Libby server. There's Spark for TensorFlow cluster. There's Helm for TensorFlow clusters. And with this type of integration, you can, with very simple commands, you can launch and destroy these clusters once individual tasks are completed. On the internal side, we also developed a Kubernetes executor. After doing some initial testing, we decided that we get a lot of gains from, rather than having static workers, we would follow more of a Kubernetes convention of having individual tasks that are mortal, where each task that the executor gains, it launches a brand new pod for that individual task. What ends up happening is that pod is started with a distribution of Airflow such that it can run just that one task without having to worry about like heartbeating or anything like that, and then the pod dies. The big upsides to this is it massively increases scalability and like elasticity of the cluster. So if you're not currently running any job, you don't have any static workers that are wasting resources, and if you suddenly get a massive influx of jobs, you have much more flexibility to grow out where you're not limited by the number of workers you already have statically running. The downside of this is that each worker will have some amount of startup time, though that's heavily dependent on the size and number of DAGs you have for an individual Airflow instance and the storage method that you're using, which is something we'll discuss a little further later. At the high level, the Kubernetes executor doesn't change anything about any of the operators. Because it's running an individual Airflow instance, it works pretty similar to how the Mesa executor works, where it basically transports that one command for the Airflow run with whatever arguments it needs to that pod, runs that one command, and then Kubernetes will report back whether that pod succeeded or failed. So as I mentioned, you have the main Airflow instance that creates these miniature Airflow instances. And one thing that was a really nice kind of addition with this is that because we can inject all the information to speak to the main SQL Alchemy backend for Airflow from all of these slave pods, we don't have to, as the scheduler, find out like what the end result of that task was, because it will still bubble up to the UI through the fact that it's actually changing the Postgres data itself. One interesting problem we ran into was how do we propagate out these DAGs to each of the Airflow workers? And there was a lot of discussions about this. We discussed GitHub, we discussed NFS, we discussed CephFS, and what the conclusion we finally came to was that the best solution we could have is to kind of leave that up to the user while offering certain defaults that they can use with ease, and then kind of creating an extendable plugin where they can create their own Kubernetes volume mounts. So that's where Kubernetes volume mounting comes into play. And the way that Kubernetes volume mounting works is that you can basically take a certain directory in a Kubernetes pod and kind of sub it out with an external dependency. So you can say, this will actually be linked to a certain GitHub repo, or this directory will actually link to an NFS instance. We figure that to start out with, we can offer GitHub, EFS, and Cinder, and then if people want to add more, they can either do that using a plugin, or that's definitely future work that can be committed into this project. When it comes to monitoring, we decided to use the Kubernetes Watch API. This is a huge this was a huge benefit over the original idea, which was taking a poll of each task to the Kubernetes API. What's really nice about the Kubernetes Watch API is that it's passively retrieving events from the cluster, and then we can just handle those as they come in. So you can have much larger number of tasks running, and you're not constantly polling. Instead, you're just receiving major life events from each of those tasks. This allows us to discover if a pod failed, then we obviously bubble up that failure to the user. And if the pod passed, then that means that the pod itself has already reported the final status of the task itself to the Postgres instance, meaning that we don't need to do anything. We can just eject it from the running queues so that the scheduler knows to add in new tasks for the executor to run. When it comes to error handling, Kubernetes actually keeps pretty good logs of low-level actions being taken by pods. I recently spoke with Dan Davidov from the Airbnb Airflow team, and from what we discussed, I understand that there's an intern on the team currently working on kind of doing the lower-level logging with the and hello, that is the intern. Working on some of that logging from Kubernetes back to the Airflow instance. So as long as all that can be brought back into the Postgres instance, then the users will have a very good understanding of what went wrong in their tasks. Any failures at the task level rather than at the pod level will be reported back to Kubernetes as just a failure in the Postgres instance. And so those are kind of the main things that we're looking into as far as the error handling. There's definitely some future work left. One major thing is, of course, the Helm integration for cluster management. We're also at the early stages of using Kubernetes etcd, which is a key value store database, to enable cross-communication between pods. So that's So those are the two main things we're looking into right now. But other than that, I'm really excited about this meeting. I definitely look forward to getting some feedback and also some feature requests and just kind of bringing this out there to get some general discussion started.
So is Airbnb actively, you mentioned the intern is working on this, is Airbnb actively working with you on this, or are they working just smoothing out deploying Airflow via Kubernetes?
Sorry, what was that?
Sorry, my microphone's kind of shitty. You mentioned Airbnb's has an intern working on this.
Mm-hmm.
Are they working with you on the executor or the operator and executor? Or are they working on mostly smoothing out the deployment of Airflow via Kubernetes?
Sorry, that's just unmuted. Yes. So our intern's working on like a logging abstraction right now. So like that logging right now, the logs are stored locally. And like at the end they're shipped to S3, but our intern is working like on a logging abstraction that'll allow you to ship logs to, for example, Elasticsearch. So that'll play a lot nicer with kind of the ephemeral workers that Daniel's been talking
about. And you know, like in terms of priorities, so I think so we're moving all of our microservices like slowly over time to Kubernetes, and it's becoming a priority, you know, over time. But I think Bloomberg was a little bit ahead in just in terms of like where it fit in their priority list. But for us, definitely like a Q3 thing. I think I'm not sure exactly when, but we're planning on. I think as soon as we can like we can use Kubernetes for all of our tasks, we're going to be running them that way. And you know, it solves a bunch of problems for us. Of course, it's like the right way of doing things, and it's really obvious. Like having Docker and you know, having containment for not necessarily for free, but for really cheap makes tons of sense. So it was like becoming a top priority, maybe just a little bit after Bloomberg kind of took the lead on that, or Danielle took the lead on that. So we're following the footsteps, and it looks like everything that's been done so far is very sound. I mean, that's the executor abstraction was created, you know, originally with this in mind. So the idea of being able to use whatever way of running things. I think for logging, you know, I'm not sure exactly where we're going to with this, but there's of course, I think in a similar fashion that there might be different approaches on how we sync the DAG definition. Here we might need also like kind of some sort of some level of flexibility for logging too. I think there's already kind of support for on the S3 side, right, to persist the logs and ultimately get them out of there beyond the pod's lifespan or the worker's last lifespan, whatever the executor may be. We might, you know, it seems like it could be nice too to have links to, and I'm not sure if it exists in the UI, but to be able to easily from the Airflow task instance to jump into the pod. And I'm not sure what happens too in terms of like when the pod is dead for ephemeral pods. So I've been working with Kubernetes for another project for kind of long-term pods. So is there limitations there in terms of like introspecting what happened after the pod has completed, or how does that work? Anybody's got some input on that?
Ani, would you have anything to say to that?
So in general, like two different points, right? First was the UI, and there's this concept of custom resources, previously called third-party resources, that integrate with the API and let you put in domain, like application-specific information into it. So you can extend the Kubernetes API at runtime with these objects, and that's where I expect like each Airflow DAG to have, you know, status reported about it. That would be the integration with that. And then I guess your second question was, sorry, I forget.
It was around like what happened. So for an ephemeral pod, like the retention of the visibility into what happened, like does that stay there, or once the pod, you know, is gone, is it harder to access, or does it get purged?
So we do the same thing like with Spark on Kubernetes, and the way that it happens is we keep the pod around after it's completed, and eventually garbage collection kicks in to clean it away at like when you have 12,000 odd pods, and that's configurable. So in general, you will have completed pods which are stored as tombstones to have access to its standard error and standard out for as long as you want.
We probably want to release that as quickly as possible. So get the logs, to flow some other place. And then, when the task instance is done, garbage collect those pods as soon as possible, because we'll be generating a lot, right? To say at Airbnb, we run, say, 80,000, maybe 100,000 tasks every day. So we need to garbage collect the pods so that they're free to run more tasks.
So yeah, in essence, the completed pods are actually not consuming any compute or resources. They're just tombstones. So all they're storing is the logs and the completion status and things like status and etcd. So there's no great overhead of having them around. And when I say garbage collection, I mean that instance, the reference to it in etcd goes away eventually. And it's usually not concerning.
Got it. So it's not actual physical lots are not being used. It's
no.
Okay, good.
So I just got a question through the Zoom chat from Victor Montero. I have one question related to the Kubernetes executor. Is the executor going to create a single pod for each task, or is it going to be similar to the Mesos Celery, which is a shared which is basically static workers? Victor, the idea here would be that this would actually create a new pod for each task. So the big benefits there is that you get that elasticity, and it also kind of fits in better with the Kubernetes philosophy, where you don't want things heavily dependent. You don't want to be heavily dependent on a just high availability worker. You would want to just kind of launch this task, run a single thing, and then have it go away so you can have resources opened up for other things. And Chris R has a subsequent question.
I have one thing to add to that. I think one thing, Daniel, you mentioned was the startup time that might be a concern. The startup time is usually associated with just fetching the image from the registry, the Docker image, and that is cached on the node. So if you're reusing the same image for all of your executors, then you actually amortize that cost, and you don't have to pay it multiple times.
Except for the DAGs, that might be the bottleneck here. So their DAG folder has to be separate. We can't really bake that into the Kubernetes image. Maybe some kind of seed, but.
If it's a fused, if it's a file system in user space or something like that, that can be pretty quick to just latch on top, depending on the mechanism. So depending if we do a Git shallow clone or something, or whether you just kind of latching on some NFS virtual external drive, that can be instantaneous. There's a notion. Eventually, we want to be able to have better support for versioning, and say when we start the DAG run to know which SHA to have say consistent DAG version throughout the DAG run, and so that means that eventually we might want to support something that's more like a Git shallow clone, so we can fetch the exact version of the DAG that we need.
So,
but again, that's it. The cost might differ depending on what you're trying to accomplish.
So just to that point, Kubernetes, the Kubernetes GitHub volume mount actually does have an option to give a specific Git commit hash, so you can have that assurance that throughout your entire DAG, it's still running the exact hash from when it started.
That sounds perfect. So that is done as you mount it or something like that, or is it done as a subfolder? I know there's something that exists too. There's a Git file system in user space that allows you to have the first folder level of your Git repository becoming a Git ref, which can be a SHA or a tag or a branch, and that seems like it's a way to do that virtually too, without say cloning the repo.
I actually haven't heard about this. Is it just called a Git file system? That's definitely something I'd be interested in.
It's called Git repo, and yeah, it's a volume type that you can specify, and then have the repo, what branch you want, and so on, and it'll clone and put it in that mount for you.
Yes, we're talking about a Kubernetes construct. I was talking about something we use at Facebook. I'm not sure if it's internal, but it was a Git, file system and user space specific thing. I know there's a Microsoft project around that does something similar. So it's just like a fuse. And it sounds like Kubernetes got a construct on top of one of those, or got its own thing.
Yeah, this might be different. Sorry. Yeah.
So I have a quick question from Fenglu. Quick question on the Kubernetes operator. You mentioned that it'd be useful for dependency management. Do you mind elaborating a bit more on that? I imagine if you have downstream tasks that depend on this dependency, the scheduler will have to start the task pod from a different Docker image, possibly out of the K8s operator. So just a kind of high-level overview of how we were imagining doing this is, so for example, with like a scikit operator, you could basically create an operator where you give it like the GitHub link to where your like scikit file is, and it launches a brand new pod with all the scikit dependencies, and then pulls in the Python, like whatever scikit file from GitHub that you link it to, runs some sort of a run command, and then that way whatever training or model fitting you need is done in the pod level. As far as downstream dependencies, I would imagine like I think that Maxime and Dan, please correct me if I'm wrong, but I believe that the Airflow philosophy is that each individual task should be idempotent. So because of that, there shouldn't be a downstream dependency where besides cross communication, there should be like any shared state between pods.
Yeah, that's right. That's right. That's the philosophy, and that means that the scheduler, if there is a downstream dependency, then the scheduler is going to realize the state of the previous task is done, and it's going to schedule the next task over, and and that will create a new pod. So there's no like kind of slot recycling in Airflow, though we thought about that at some point to be like, hey, maybe instead of having kind of distributed scheduling where as the task finishes, it would try to schedule its dependents. But that does not exist. And if that was to take place, it would go through the executor message queue and be redistributed. Maybe a follow-up question is around like the Docker instance. So we've been thinking about adding in base operator, maybe like a Docker instance ID of some sort, so that any task can be set to use whatever Docker instance. So how are you thinking about like specifying which Docker instance for each task?
So I was imagining that being something where either it would be done at the user level where someone's creating a plugin, they designate a Docker image, but that's also where Helm would really come into play, where Helm could basically have like stable versions of scikit-learn and a stable version of TensorFlow and stuff like that. So you could potentially link to those, or we could just take an opinionated stance and point to specific images on Docker Hub. Sorry, 1 second, guys. I am running low on battery. I just need to go grab my charger really quickly.
It seems like it's just in terms of like information, we need a place to reference the Docker ID. And, in the case of the Kubernetes operator, it would mean, to fetch that Docker image ID in the way that Kubernetes does it. You can picture like how other executors might or might not support that construct of like, say, Docker ID. And I'm not sure like where that happens. In some cases, so say in the case of the Kubernetes operator, you need to know upfront in the setup phase, what the Docker ID is, so you can create the pod properly and inject the tasks inside of it. You could also, like in other contexts of other executors, there might be more of a bootstrap thing going on too, where say the Airflow run would kind of spawn its own Docker image and run and injects it itself inside of it. But I'm probably like thinking a little too far here. But yeah, I think in any case, it'd be good to add, I think, Docker image ID or image ID, because maybe Docker might not be the only solution forever. But yeah, maybe like something like image ID in base operator, so that every task can specify which image it should run as part of. And then there's a need for these images need to have Airflow inside of them too. So you'd have to have like a base image that all of these Docker IDs have in common, and then on top of that, whatever layer they would need, whether it's like scikit-learn or some R dependencies.
Yeah, exactly. So I think that that was just kind of like examples of things that you could do. I think that it is fair to say that there would have to be some dependence on the user. So, for example, if you're using an internal system like we do, where we don't actually get full access to Docker Hub, perhaps we can kind of give that option of like, hey, this is a scikit-learn operator, but we know that not everyone has access to these specific images, so that there's actually a parameter where you can override the image to point to another image that has scikit-learn, but it at least keeps it clean at like the DAG UI level where you see what you were doing.
So we kind of addressed a similar problem, I guess, in Spark when we were doing Spark on Kubernetes, and there the approach we went with was publishing these Docker images which had this the entire distribution baked in, which is sort of the base.
Mm-hmm.
And if people want to customize it, then they can go ahead and do that. But I'm guessing like this might not be applicable here because there are far too many of these different images and frameworks. Would that be accurate?
Sorry, could you say that one more time? You think that it might be problematic to do it? Thank you so much.
No, like in the Spark case, like we publish these official images that people can use, or there are sources if people want to extend it in some way.
Oh, I mean, so like as I had mentioned before, that's kind of like one potential benefit of Helm is this kind of normalization where like everyone gets the exact same image. Okay. No, I'm good. Thank you. But I do agree that like I don't want to be the one in charge of that, so I would hope that this would be something that is either everyone takes a super opinionated stance on, or we just kind of leave it to the users that like maybe we'll create one or two example ones as a way for the users to say, by the way, these are ways that you can build higher level dependency agnostic containers for Airflow, just to show them how it would work.
Okay.
It's kind of from there's like this idea of like, hey, are we in charge of picking up the Docker and bootstrapping it? I think in the case of Kubernetes, it's not the case, right? In Kube, it's just a configuration thing. As we start the pod, we would say, here's the image ID that we want. I'm curious as to like, I haven't looked into Kubernetes support for different like artifact store for Docker images. So how does that work? I guess like I'm guessing that somewhere in Kubernetes there's an abstraction where you define where you store all of your Docker images and then how you reference them. And for different people, it might be different things, right? It might be Docker Hub, or it might be you put them in S3, or you use that Artifactory or something like that.
Each pod has a specification of the image and the command that you want to run within that. So that's part of the execution unit itself that you would specify what Docker image to reference.
And so one thing I did with the Kubernetes executor was I actually made it a configuration in the airflow.cfg that like, hey, if you're trying to run like this specific command, like this is the actual link to the Kubernetes. This is the actual link to the image of the Airflow slave. We could potentially do something very similar where we actually have like a section of the airflow.cfg to point to like these are like the baseline Docker Hub images that will be used for each of these operators, but you can override that in the airflow.cfg so you don't have to actually do anything in the code level.
Yeah, so there's the need for that, right, to specify what is the base image as a configuration thing, but then there's the need for users to create their own Docker images that they can overload with extra libraries or specific versions of things. So I guess there would be a base Docker image ID or something like that that would act as a default, and then users could derive that image and reference it in their tasks to say like this specific task I wanted to run in the scikit-learn Airflow Docker image or something.
Yeah, and so then one big benefit there is that you could actually like kind of abstract that and say like here's a pod operator with the scikit-learn dependencies, and I'm the Airflow guy for my company. I don't want the data scientists knowing about all this internal stuff, so I just wrap all that in an extension of the pod operator that I call the scikit-learn operator. And so you could do that with all sorts of different dependencies that Airflow itself doesn't have to kind of really expand what it could work on.
So that was kind of my question. It sounds like in the base Airflow CFG, there's the ability to specify a default Docker image to use if I just use some random operator. Is that true?
No. So if you use like as it stands right now, the Kubernetes, like the pod operator, does require you to actually state which image you'd want to put in. So if you're just using the pod operator, that's Sorry.
I guess that's if I back up a second, I think that might be the question I'm actually getting at is if I use a Docker executor for my cluster, but then I just use Python operator, for example, what happens?
Oh, okay. Yeah. So what happens there is that the Kubernetes executor will basically launch a pre-designated Airflow slave, which is just a pod which has Airflow in it and all the Airflow, like everything needed to build Airflow. And once it launches that pod, it will basically launch it with the command Airflow run, and then whatever subcommands are needed to do that Airflow run. So it would basically be the same as if you had some sort of static worker and we're using like the pickle mode to like send it over, except we don't need to use pickle because we're actually launching with everything in there. And I know that that was when I spoke to Maxime and Dan that was a concern that they want to start moving away from pickle because they've run into certain issues with it.
So then my question stands: if you're spinning up a pod to execute this Python operator, there are two parts of config, right? One is the Docker image that you're going to use, and the second is the actual pod configuration itself. Where do those live?
So yes. So I can actually show you in the source code for what we've been doing. So just as a first part, the actual, let's see, Docker file. Sorry, give me a second. So, too many projects open. Yeah, so I mean, I actually do have it in the. So like this would be an example of what some of these options would look like. So you could have a KS mode. So currently this mode is Git because I'm using the Git repo. So for that I need the link. So I use my personal access token and the actual DAG folder, and I also link to the KAS image. And then this will be this would default to like Docker Hub /Airflow or something like that. So there would be some baseline image, and if for some reason someone wanted to modify their Airflow image and add stuff in, they could change this in the configuration.
Okay, so just to summarize, it sounds like the config for the pod and the Docker image will be in Airflow CFG for the defaults.
So the config for the actual like which one to deploy will be there, but we also would have a pod request factory where we can take in a lot of the we have this kind of baseline YAML file that we then take in, and then we extract the actual names from the request and the command, the label, the image, and we build around that.
Okay.
So
I guess a follow-up question is based on that DAG. The whole discussion around DAGs here, it seems to me to be making the assumption that there's a monolithic single like Git repo where all the DAGs live. Is that true? Or is it possible to have different repos or different artifacts that you can pull from?
So I'm basing that more along the lines of like those are the extremes. So like so if you are running a company where everyone is in just one gigantic DAG like repository, that's something you have to consider. What I can say personally for what Bloomberg is going to be doing, as like Bloomberg is a really security obsessed company, and one big benefit we're getting from Kubernetes is that we're actually running individual Airflow instances on a per namespace basis. So the idea there would be that each namespace would like you could actually like have just like one DAG folder per like each namespace. So we don't actually expect our instances to get that large. So the DAG transportation startup time for us would be pretty negligible.
Sorry, you were a little choppy there, but if you flip back to the Airflow CFG, can you do that real quick?
Yeah, absolutely.
the thing I'm getting at is that Git link that you have in the Airflow CFG
Yeah.
For the DAG repo. Like that is basically a single Git link for all the DAGs that Airflow instance is running, right?
Yes.
Okay, so wouldn't that imply that the assumption is there is a single Git repo where all the DAGs live, as opposed to like the risk team has one DAG repo, some other team has another DAG repo, and so on.
So this is the implication here is that this is the Git repo for the DAGs for this Airflow instance. What you could do if you were the person running the cluster is you could, and what you probably are doing is having separate namespaces for separate teams, so you have that like security and isolation, and each of those namespaces has their own running Airflow instance that can then basically pull in from different Git repos.
Okay. So basically, you would have to run like federated Airflow if you wanted, versus a single scheduler for everybody. Okay.
Yes, sir. Another question, I think something that's important to talk about is whether we want to enable any operator to run on any Docker, or if there's like constructs there that are more restrictive. And that, it sounded like when you were talking about maybe like a specific operator, like a pod operator and derivatives from it, it would assume that it would be mostly just Python operators that would be, pre-assigned to a Docker or something like that, to a specific Docker image or something like that. For me, like one thing that I thought was empowering was the idea that you could specify in theory like any basically task could be a combination of any operator running on any Docker, which a bunch of combinations don't necessarily make sense, but then it's like ultimately it's very flexible where you can say, I want to run a Hive operator with this different image with a different version of Hive or something like that. Or I want to run this Python operator or the sensor with a specific Docker image. Then like the big matrix, even though like the combinations are probably just, most operators would just use the default Docker image ID, and then most likely Python operator is the one that would need to have to use all sorts of different Docker image IDs. So the whole matrix would be very sparse, but then it would be possible to do whatever.
So there definitely is that possibility where we could basically, so for example, with the Python operator, you might be able to specify like which version of Python you run, and then you could have multiple versions of Airflow, each of which with different versions of Python or something like that. I haven't personally looked too deep into that yet, but that's definitely something I'm totally open to. I would just want to discuss it further to make sure we do it in a way that doesn't overcomplicate everything that we have so far.
Yeah, so a quick follow-up question on that. I know there are various modes of executors.
Yes.
I was thinking like for the ones that we talk about a lot about like image customization and whatnot. So does it make sense that for all the operators that needs to have special sort of like a port config, images, namespace, etc., can we have those operators simply extend your kids operator, make kids operator like a base operator for the ones that you want to customize your things running in Kubernetes?
So, I mean, I think that if I understand correctly, I think that is the idea that like the Kubernetes operator is just kind of a low-level operator. You can use it as like a direct operator if you want to, if you are someone who's inclined to do that. The main issue there being that then your actual DAG UI would end up being hideous because it would be nothing but pod operators, so you wouldn't get like the actual feedback of what each task is actually doing. But yeah, I mean, it would be like a baseline for or actually, could you ask one more time? I just want to make sure I understood correctly.
Yeah, so I've heard a lot of discussion about being able to specify different image versions for sort of like existing Airflow operators like Python operator, maybe a bunch of others.
Mm-hmm.
I want to make it clear from the community that I know there are other executors which the image ID may not make sense in those contexts. Mm-hmm. So I just make sure that if we, let's say, does it make sense we divide into two categories? I mean, for the ones that are generic to all executors, keep existing ones. For the ones that you want to customize the image, and then that seems to be more in the context of Kubernetes, can we just subclass those operators under your kids operator? That's my question.
I think that's actually a very fair point. Where if you want those level of customization, then defaulting to say, hey, if you want to run this new version of Python that Airflow doesn't support yet, just get a pod that has that version of Python and create an operator around it using the pod operator. I personally think that's a very fair point to kind of keep things clean on the actual Airflow side.
Thanks.
I got a question from Bulk about OpenShift. Is it Bulk or Bulke? I don't want to mispronounce it.
It's Bulker.
Bulke.
Yep.
Thank you. So I haven't personally looked too deeply into OpenShift, but it's definitely something I'd be very open to. I know that Bloomberg actually uses it as well, so that would be just one more win in our column. I do know that it would not be too hard to create a Cinder volume mount, and I think that if I am correct, Cinder is the default kind of distributed file system within OpenShift. Is that correct?
Well, you can use Ceph, Cinder, NFS. There's a couple. I think the choices that you can make with Kubernetes are mostly, I guess, available to OpenShift as well. OpenShift is a management layer to do Kubernetes on-premise, basically.
Oh.
So for this one, we did similar things with Spark, HDFS, etc. The effort is pretty minimal as long as you're ensuring that you rely on features that are Kubernetes 1.5. Like if you're building for OpenShift today, then some of the 1.6 and 7 features aren't in there.
Mm-hmm.
So as long as you target a slightly older API version and make sure you're not relying on bleeding edge features, it's typically very little work to make it do the same thing on OpenShift.
Okay, that's an interesting point because, so I know Anirudh that we had discussed pod presets. That was one thing. Were there any other major features we'd like? Is the Watch API something recent or?
Oh no, Watch API has been there since V 1.0 forever. So yeah, I haven't seen the PRs or things in detail yet. But so far, I don't see anything that we're relying on that is super bleeding edge.
Yeah, I know that on our end we're using pod presets just to kind of fill everyone else in. Pod presets are kind of a form of injection where you can specify that any pod with label X, Y, or Z gets these config maps, these environment variables, these sidecar containers. I know we're doing that for our operations end of how we're launching our Airflow stuff, but I think we might be okay on the actual PR. I would definitely love it if you could look it over and see if there's any bleeding edge stuff that I could do a slightly more old way. So if we can get everything working with 1.5, then we should be totally fine.
Yeah.
Let's see.
I haven't looked at the PR, so I should probably look at the PR, but it seems, one thing I'm curious about is the amount of setup up front. So how much Airflow can we abstract kind of upfront on behalf of people versus how much time or how much effort it takes to set that up for people who want to do it. So as part of the PR, do we have the documentation kind of installation procedure for the Kubernetes executor? And I think that would bring a lot of clarity, just reading through the documentation for, hey, I have Cube at work, we're running Airflow. I want these things to work together. How do I go about it? What are all the steps that are necessary to do? So do we have that in the docs now?
So
how long does that look like?
So I haven't created the documentation for it yet, but it's actually not that hard to set up. I know that for me, besides setting a few of those 3 configs you saw where I point to the image, the git link, and the Kubernetes mode, I was able to launch everything from the ground up with one deployment. So right now, with just a single kube deploy, I set up the scheduler, the web server, the Postgres instance, and all the interconnections between. I don't see any reason why we can't also do some form of open sourcing for the actual deployment script. I think that there is already some form of Docker-Airflow on Docker Hub, but I'll definitely include an example deployment script to just give a sense of here's how you can just kind of drop and go with what we have.
Yeah, I think that documentation is a really good place to start. Even for it to be part of the PR. So say the PR is out, I would read the docs part of the PR first to try to really understand what's the approach here and what do I need to do, and then that will bring clarity on the code that is behind, because I guess it defines the installation instructions kind of defines the approach or what we're expecting people to do to make that work in their environment.
Absolutely. So a couple more questions. Amit from WePay asks, can we run the Kubernetes scheduler as one of the Kubernetes pods, or do we have to run it outside the Kubernetes node pool? So the way it's set up right now, and if there's a strong opinion otherwise, then we could definitely do it some other way. But the way it's running right now, it actually fully assumes that it is a pod within the Kubernetes cluster. We use the .incluster config function to actually gain all the to set up the client to speak with the Kubernetes to launch the pods. It's slightly less trivial to do so from outside of the cluster itself, but if there is a strong opinion on that, I just kind of imagine that most people who would want this feature would be running it in Kubernetes itself.
So one question as a follow-up. So scheduler and web server is running together or separately?
Sorry, what was that?
The scheduler and web server process, those are running on the same pod or on separate pod?
So in my current deployment, I have them running on separate pods, but I think that running them on the same pod would have the benefit of shared volume mounting, so that they both would link to the exact same DAG folder. Anirudh, do you have any thoughts on this? As far as should we run?
It should be two different ones, because we need to be able to scale the web servers independently from the scheduler. The scheduler right now, people might want to have, I guess for now, just one scheduler and multiple web servers, so we'd be able to. So
I have a question on the web server. Is it usually just going to consume? Is it going to mount that volume of DAGs as a read-only thing, or is it also going to make changes to it? Because depending on that, you could have shared volumes where the web server is just mounting them as a read-only thing, and that would work. Keeping them separate and still sharing some storage between them.
I think for the sake of being able to scale them independently, it needs to be two pods, right, in the same namespace.
Yeah.
And then of course, and then it's read only. So the DAG folder is always just read only. There's no it's unidirectional there.
Then that totally it would work right out with most file systems and most volume nodes.
Yeah, so I mean, like I said, with the deployment we have right now, we do run them on a separate. We do actually run them on separate pods. One thing we can do is, especially if we're doing the Git hooking, is we can run a sidecar on each of those that continually syncs with GitHub to make sure that whenever you if you want to modify the DAG, all you have to do is push it to GitHub. Then the Git sync will pull that into the DAG folder, and then the scheduler will read the new file and then upload it, so that everything is in line with each other. Got a question from Dan. How does the scheduler process the Kube Watch API missed requests? Example, if the scheduler is down for a period of time. So the way we have it set up right now is that the Watch API runs on a separate thread. We didn't want to be dependent on the actual scheduler heartbeating to. So it actually works fairly similar to how the local executor works, where you can launch these sub processes that all they do is consume from this API and then use Python shared queues. So every time it receives an event, it parses through: is it a failure? Is it still active? Is it pending? And based on that, it will place things into the watcher queue, which then the scheduler itself will sync up next time it does a heartbeat.
Wait, so if the scheduler goes down, though, the thread's down too, right? So.
Oh, if the entire scheduler server goes down?
Yeah, the scheduler's down for a period of time.
That's actually a good point.
I haven't seen how the implementation works, but here's how I've seen it work elsewhere. It's usually you watch resources by providing a resource version, so that even when you're out of commission for a while, when you list all watch events starting from that resource versions, you get all mutations to that resource. So a brief disconnection or a brief outage should not matter. But in case there's a prolonged outage, then we'll off recomputing state from the existing things out there, from checkpoints or whatever. So
yeah, just making sure that we're like aware of that, like the implementation.
Yep.
No, that's a very good point, and I think that that's something that we should I'll definitely implement into the watcher to like make sure that it actually is storing those checkpoints somewhere, maybe an etcd or something, or something, or maybe even in the Postgres instance, just something that's stable so that we make sure that we don't miss those events.
Yeah, but in general, like a few thousand events, if you were to lose in between, the API server would still, like it would still keep track of those for you when you reconnect. But yeah, there's a mechanism to recover from a complete outage as well.
Yeah, I think it's safe to restart the scheduler at any point too, right? It just might re-trigger some tasks. Or
I think, I mean, so like the way they're doing it, they're not storing like the state of like heartbeats or something in the database. Instead, they're getting like notifications. It's like push instead of pull. So that's why I think there's like. It's
okay, so you cancel the heartbeat mechanism because it's redundant.
Yeah. So I mean the way that it works is that I created a Kubernetes mode. So when you launch the slave instances, it does like -km, and when you do the -km, rather than triggering the heartbeat, it just I think it works similar to how the pickle segment works, where it just pulls the executor, does a task on the executor, and then ends gracefully.
Because there's alteration to all the heartbeat stuff, and that means the scheduler is not watching for killing tasks that are not emitting heartbeat. Okay, so that would be like the part to be really careful of reviewing. Yeah.
It's good though.
Yeah, it's good because all that machinery, it's all taken care of. Oh yeah, so all that machinery will be taken care of by Cube, so that's much better. Because the heartbeat stuff that we have now, and the scheduler kind of try to lining things up and handling failures has been not so kind of a hard part in the logic and the code, and so that mode of operation will probably be much better if done well.
Awesome.
So I just wanted to underscore something Maxime brought up earlier around the Spark operator example you gave, for example, where it extends a pod operator, I think.
Mm-hmm.
And I think it's worth thinking through the model for that, whether you do an extension versus more of a mixin, where an extension kind of locks you in on some of your configs versus a mixin where you could potentially mix in different configurations for the same operator. So have you given that any thought, or do you have any opinion on that?
What do you mean by a mixin?
I mean, so for example, in the extension model, you're basically locked into whatever the pod operator is going to set. That's what I'm assuming, as far as configuration goes for the pod. Versus if I had the ability to say I want to use the scikit operator with this set of pod configuration versus that set of pod configuration.
I would imagine it's kind of up to the creator of the scikit operator to say, these are the things that I want to be static, and these are the things that I want to leave to the user to decide. Okay,
so the idea would be for scikit operator, you would potentially expose like the Docker image that you want to use.
Absolutely, but with like a default Docker image. But if and the example I gave before is here at Bloomberg, we can't pull from Docker Hub. So for example, the scikit operator has a default scikit Docker image. But if you need a different one, just add one in, and you'll still get at least the UI benefits of knowing that this was a step that was performed with scikit.
I guess the trade-off there is just that it starts to peg the scikit operator to Docker and or Kubernetes. So if you think through like the Python operator, for example, if I do some pod Python operator. Now we have two operators that are effectively the same thing, but one of them is pegged for Kubernetes versus a model where you just have Python operator and then you have some other way to attach it to a pod. Then you only have one operator, right? You see what I'm getting at? There's a little bit of a duplication thing there.
Yeah, it's like, and then there's like a many-to-many, like the same operator you might want to use on different Docker, and the same Docker you might want to use on multiple operators.
Right.
So I think not knowing where the matrix should be built, and also not knowing, I don't want to force people to derive things in order to pick a pod they might have created and they want to use. Right. So say if someone is like, hey, I've got this a data scientist that's like, I've got this very specific things. I'm going to push a Docker and I want to run the Python operator against it. I want to run like whatever operator against it. We might just want to add it to base operator and then leave the whole like the flexibility on using whatever operator with whatever Docker. But that can be confusing, but then you could create from that new operators that force the image ID, right? I could create a scikit-learn Python operator that does not expose the image ID, but like forces it in. I don't know. But I wouldn't want to limit things and assume that every time you want to use an operator, an image, you have to derive a class. Maybe.
Yeah, I think that's my concern as well. And I think there's a tension here between how baked in you want the Kubernetes stuff to be in Airflow. The more baked in, the kind of more intuitive and easier it's going to be, but also the more invasive it is for stuff that doesn't care. So this model is, as I see it, is basically not very baked in at all versus something like an integration with base operator where it's sort of, there are parameters there that are like useless basically if you don't use Kubernetes.
So, I mean, as far as how baked in, like I always imagine that this would be something that the person in charge of Airflow for the company would create, or like a team that knows what they're doing would create. So at most having like one or two Kubernetes specific operators just as examples. So we could have just like a K scikit-learn operator just to show people here's how this works. And then if you want to do this, just use the plugins, because like a big concern on our end was, especially since the product we're building is for data scientists, we don't want the data scientists just seeing pod operator, because that doesn't give them valuable feedback about where they are in their pipeline.
I think what Chris is mentioning is rather that we currently already have a set of operators available within Airflow, and it's nice that you provide a kind of way. What Chris mentioned is also a Pythonic way of doing things, is having a mix-in that allows those existing operators to operate right away on a specified Docker image. So not a dependent one, but just because you mix it in, it allows you to specify the extra details that allows you to use those operators directly. Just reuse them across the what's needed. So you don't need to redo or recreate any special operators for it to run on Kubernetes per se.
Yeah, one of the foundational ideas behind Docker and images too is like that any developer would be baking their own images, right? Or it's like the burden, who's in charge of creating images? Whoever is writing the code, I would say. So I think in some organization you might say that it's the Airflow, the people who administer the Airflow cluster that would define what images can be used. But like the real promise, I think, of images is that the person who writes the code can bake their own image and tell people, this is the image I want to use, this is the code I want to run, and that's the operator, not in the Airflow sense, but the people. The contract is just, I'll run your code inside that image on my platform, right? So anything short of that, I think, there are use cases where in your use case, you might not want to let your data scientists, specify, a specific version they want to run, or you don't want them to go crazy starting to bake all sorts of images. I think in our context, we want to enable maybe not data scientists, but like engineers to be like, hey, I want to bake an image for whatever reason. I have a good use case. I want to run my Airflow job inside of it. And we don't need to know much about the image except that it derives the base Airflow image, I think.
So this whole concept is kind of consistent with what we see outside with people using Kubernetes. There's the production use case where you want a strictly maintained set of tags and images which are vetted by people and only run. And there's the experimentation and daily developer workflow use case where you just want, hey, here's my image, here are my dependencies, run it for me, and self-service type of thing. So I think there's an argument for both things here, and we should be looking to do both.
Well, and I wasn't saying that we weren't going to expose the pod operator. Like, I think that if people want to bake in their own images, they totally can. This was just one example of somewhere where I could see it being useful, but I definitely agree with giving developers the flexibility to like just bake in whatever images they already have. Maybe with the extra ability to just kind of like write in some metadata so that it shows up differently in the UI so they can see what steps they're running.
All right. Yeah. So I think we need to expose the functionality and make it kind of easy, I think, to run any operator inside any image, but then make it easy for administrators to enforce correlations too. So perhaps, like, I know there's that policy function, which is like an administrative function in settings.py that you can override. I can say, if it's this operator force this queue, or if it's this operator force this pool. Mm-hmm. Similarly, we could say, if the user is not a certain class of user, or if this operator force this pod, or do not allow for say pods that don't exist.
So on that note, like, what is when you say user, like what is the notion of user here? Is it the Unix user who's submitting it, like, or do you have service accounts or something else?
Pretty much service accounts.
Yeah, for us, it's like the author, the self-described author of the DAG. So in some cases, we will impersonate people, so it's a feature in Airflow, but like the DAG as an owner, or is it the task that has an owner? So I think each task has an owner, and then we can impersonate that person as we run the task, but it's really just metadata as to like who wrote it, who owns it.
Okay, so people are generally trusted to put in the right self-described credentials there and go like their own username there.
That's right, but though I think we're moving towards service accounts. So.
Okay.
Great.
I want to say this is super helpful to have this conversation, and thanks, Daniel, for all the work that you've done. This is like super great, and this is like the reason why we open source in the first place is like we like to give, but we also like definitely like to receive too, and we're super happy to see that it's moving forward. And I think the chances are good that if we do the work well, that we can all use the same constructs and the same foundation, and that we'll all save a bunch of time.
Awesome. Yeah, thank you. I'm glad to hear that the reception is generally positive, and I'll follow up later on once I kind of implemented and kind of cleaned up some of the suggestions you guys have.
Yeah, this was super useful. Thanks, Daniel, for inviting me as well. Like from my perspective, I also have this goal of making sure that this is following the guidelines and the general principles of the rest of Kubernetes so that it doesn't stick out and is usable, whether it's on cloud or on-prem and everywhere else, without making too many assumptions. So I'll be focusing a little bit more on that, and then we can probably iterate on the PR. I don't think there's much, but yeah, it's an awesome stuff.
Awesome. Yeah, definitely look forward to some feedback from you, Anirudh. And great. If that's it, then thank you guys for joining, and I'll be posting a video of this as well as the slides onto the Airflow wiki.
And can you guys do like is this group the right group to do like a follow-up meeting maybe in 2 or 3 weeks to kind of see progress and where we're headed, stuff like that?
Yeah, I think this is definitely the right group of people to speak with.
Okay.
Just do the invitation on the mailing list if you don't mind.
Yeah.
That's an Apache thing.
Absolutely. I'll use Zoom this time.
Excellent. All right. Thank you, guys.
Great. Have a nice day, guys.
Yeah, thank you.